Shannon Bothel. I am the pre-AP geometry teacher at Airline High School in Bossier Parish. As an educator, I am very passionate about creating just a positive learning environment for my students. Math is not everybody's favorite. It is my favorite, but everybody doesn't love math. But I have found if we can create a positive learning environment for students to feel confident, feel comfortable asking for help, and know that I want to help them, that they tend to perform better and do better. We always include hellos when they walk in the door. I talk to them when I'm checking homework, walking around the room, and I make sure that they know that I care about them and just want to know more about them. When we form those bonds and we form those relationships, my students tend to want to do better, want to perform better because they know I care about them, because they know I love them. I'm invested in them, and so they invest more in the class. I use words of affirmation constantly. The students just leave feeling more confident and just better about what we've done each day. I know I can't make everybody love math, but I'm hoping I can help everybody to at least like math a little bit better. Throughout the semester, we're able to really build our skill set, build our confidence, and make sure that students feel good about what they've learned and how they're going to perform better in their future math classes, because I'm not the end of the math route for them. They have more to do, and I'm hoping that I can just feed into them with positive affirmations, relationship building, and just really creating an environment where they can do their best and be their best every day. I have 9th and 10th grade students in the class that you're about to see. They are pre-AP, so I have one 504 student who gets preferential seating and one EL student who I just check in on him and make sure that he's understanding what's going on. In this lesson today, we're going to be doing angle of elevation and depression. Most of our stuff comes from the springboard curriculum, but today we're going to be applying what we already learned. We learned how to do the trig ratios, which is SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. We will be applying that today, where we also have already learned how to find missing sides and missing angles. So we're going to use all of that to be able to create our own triangles today using real world scenarios. So the goal is that they can create the triangle from the real life pictures, figure out what to label, figure out what we need to find, and do the math portion of it. We will be working in whole group, partner work, sharing our work, critiquing each other, all of those things just to make sure that we can really get the lesson and hit it home. So today we are going to start with our trig review. We're going to talk about the things that we've done for the past few days first, and then we're going to go into our lesson today about angle of elevation and angle of depression. Okay? So we're going to use the whiteboards for this part of the review, but before we do the whiteboards, you know what time it is. Get excited.
Opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine.
There's your refresher. I don't know how much you'll love that song. Okay, so we're going to use the whiteboards to do some trig review. So here we go. Okay, so what I want you to do is write the ratio for sine of A. Okay, so for sine of A, what is your ratio? When you have it, flip it up. First one gets a Viking voucher. All right, good job, Ethan and Leva. Keep it coming. What'd you get, Ethan?
4 over 5.
4 over 5. So remember, sine is what over what? Opposite over hypotenuse, so 4 over 5. All right, let's do the next one. Tangent of angle A. All right. Are we 15 over 8 or 8 over 15? I'm seeing both. Which one?
15.
How do we write tangent? What's the ratio for tangent? Opposite over adjacent. So which side is opposite angle A? 15. Which one is adjacent? 8. So we should have 15 over 8. All right, let's check that. Good. All right. Y'all can tuck those away. We're going to go to a worksheet now. We're going to talk about angle of elevation and angle of depression. So what we're going to do is kind of extend the trig idea, the triangle, into the real world, right? As much real world as we can get with trigonometry, right? So we're going to talk about angle of elevation and angle of depression. So any ideas on angle of elevation, like what that would look like? Like something going up, right? Because you know, like mountains have elevation, right? Okay, so imagine yourself looking straight forward, but instead of looking straight forward, you're looking up, okay? So the angle that is then created between your line of sight and looking up is called an angle of elevation, okay? So we're going to use that to do some problems. So let me give you this sheet. We're going to draw some pictures. Okay, Leah's mom is standing at the bottom of the slide at the playground waiting for Leah to slide down. The angle of elevation from the bottom of the slide to the top is 46 degrees. The slide has a vertical height of 9 feet. Find the length of the slide. Okay, so what information does it give us to label our picture? Allison, what are we going to start with?
The angle of elevation.
Angle of elevation. Where is that going to go?
Where she's sliding down.
Where she is sliding down, or where her mom is? Okay, where her mom is at the bottom of the slide. So I can see, hopefully you see with the slide and the ground, we have our right triangle. So our angle of elevation, 46 degrees. Okay, what other piece of information do we have?
How tall the ladder is.
Yeah, and it's 9 feet. So we're going to put that over here. Okay, and Sydney, what do we want to know in this problem?
How tall the slide is.
Yeah, the length of the slide, right? So our x value goes where the slide is. Okay, so let's evaluate what trig function are we working with. So from our angle, what side is the 9? The opposite side. And what side is the x? The hypotenuse. What trig function do we use when we have opposite and hypotenuse? Sine. Okay, so Levi, will you write that equation for me? So we have opposite over hypotenuse, 9 over x. Okay, when x is on bottom, are we multiplying or dividing? We're dividing. So let's rewrite this where we have x equals, and what will it say, Yasmin?
It'll be 9 over sine of 46.
Perfect. 9 divided by sine of 46. Okay, so what happens when we put that into the calculator?
X equals
4.5 what?
12.5.
Oh, can't hear. 12.5, and it's feet? Okay, so what does that mean for like a real world scenario? Like in what is 12.5 feet? The length of the slide. Very good. Okay, I want y'all to do number 4, and then I'm going to be walking around looking for a really good one to show up here on the screen. Okay? Oh, I like that. Cute, Brock. Oh, looks great.
Thank you.
Don't forget about the math part too, though. What'd you figure out on this one for 72.6? What is that?
The angle of elevation.
Angle, right? So what would that need to be? Yeah, good. Do you want to put yours on the board?
Sure.
Okay. Okay, who wants to show their picture? Bree, come on. And then how do we know that this is 28 and this is also 28? What are those to each other? Alternate interior angles. Good. Okay, keep going. Okay, so what we're going to do now, because y'all are doing amazing, we're going to do some partner work where y'all get to each do a problem with your shoulder partner, and then a few of us will present ours to the class.
So this is angle of elevation. So I'm gonna put her right here.
Is she putting that in the right spot?
What?
Is she putting that in the right spot?
Is it the person or the person? This is the mom.
Oh, okay.
Well, yeah, then the mom is the right spot. Oh my goodness.
That looks great.
Okay.
Yeah. I'm gonna pop through here. Oh, that looks good.
It does? Does it really?
It looks great. I like that you're going back and forth to draw it too.
See? Like,
It's like real partner work right there. Yeah. Ooh, good job. Here we go.
you did the triangle?
And I'll do it again. Yeah, there you go. Perfect. Now what does that mean? That answer?
That's the height of the subway tower.
Good.
It's 140.
Good. How's it going, boys?
It's going good. I'm adjusting my flag though.
Oh, of course. It looks really good though. You're doing a great job. You're gonna, okay, great. Come on. All right, explain the problem and then explain how you labeled your picture.
Alright, so in the picture, the flagpole is 35 feet away from the school. And the angle of depression from the bottom of the flagpole to the top of the school is 50 degrees.
Okay.
And which means those are opposite or alternate interior angles.
Good.
So
Very
use
good.
Tangent of 50.
Equals x of 35 because x is our opposite and 35 is our adjacent.
Very good.
So,
Perfect.
And then we multiply 35 times tangent of 50 and get 41.7 feet.
Okay, what does the 41.7 feet mean?
The height of the school.
Height of the school.
41.7.
Awesome job. Here you go. Thank you, thank you. All right, y'all make sure your name is on your paper and your partner's name is on your paper, and let's pass those up to the front of the row. I have the problem on the paper. So what I want to see on your paper is the picture. I want to see the right triangle. I want to see it labeled. I want to see your math. And then I want your answer in the blank. And make sure you label it with whatever unit of measurement goes with your answer, okay? Y'all, like 100%. Y'all did awesome. These are good. So, how do you feel about angle of elevation and depression? You feel good, like you understand it?
Yeah.
Easy stuff?
Yeah.
Good. I think it's very fun. Now you have some real world connections. Next time you're on a diving board looking into the pool, now you know how to use trig to figure out how far away you are from that tube that you're gonna jump into, right? That's funny. Good job. After reviewing today's lesson with the geometry team, we were able to kind of talk about ways that we could extend and improve on the lesson for next time. We decided that next time we will include some real world measurements, like around the classroom, around the courtyard, where they actually need to measure distances, the ground or a small tree, or maybe distances on the ground, maybe even just a student desk, so that they can use some of the trig functions with the real world scenarios, hands-on, measuring, creating, writing the equations and such. And so we thought that'd be a fun way to extend it for next time. After reviewing our exit tickets, I found that all but one of my students got the question correct. They were able to draw the triangle correctly, label the triangle correctly, and do the proper math in order to get the right answer. After this lesson, this was kind of the culminating lesson for the trigonometry section in our unit. So tomorrow, we will be reviewing the entire unit so that we can take a formative assessment on the next day so that we can make sure the kids know all of Unit 3. I want to thank you all for taking your time to watch my video. I'm hopeful that you enjoyed it as much as we did. Trig is one of my favorite units. I hope that maybe after this video you've learned a little bit about trig, and next time I'll throw one of my exit tickets your way. Thanks for watching.